Alright, let's take a look at this graphing rational equations. So, remember when we're graphing rationals we want to find a few things. The horizontal asymptotes, the vertical asymptotes, the x-intercepts, and any holes in the graph. Now, sometimes they may not have some of these, but they will always have the horizontal asymptote, generally the vertical, and they could have more than one. X-intercepts, sometimes none, or multiple, same with holes. Okay, so the horizontal asymptote, we're going to look at the degree. Okay, so on number 1, there's no x value, so you think of that as x to the 0, so it would have a degree of 0, which we called m. Now, x has a degree of 1, the n, and remember there's 3 rules. If m is less than n, then it's going to be on the x-axis. It's y equals 0. So in this case, m is smaller than n, so our asymptote goes right here. Okay? Guess I don't need the arrows on this. Now, if it's m equals n, then the coefficients will tell you what they are. Okay, like if we look at number 2, x and x, they both have a degree of 1, so they're the same. So we take the leading coefficient, 1 and 4, and that fraction is our horizontal asymptote. So I'd go up to 1/4 and draw that horizontal asymptote. Okay, so there's 2 of the options. And the third one, just let me mark these down. The third one is if the top is bigger than the bottom, then we have to divide to find a slant asymptote. Okay, so there's our horizontal. Now we simplify if possible. Okay, that's as simple as it gets. So then for vertical asymptotes, we take the denominator and set it equal to 0. So x minus 3 equals 0. We would add 3 to both sides. We get x equals 3. So I draw a vertical asymptote where x equals 3. Okay. Then the top, there's no x's, so I don't have any x-intercepts. There's nothing that canceled out, so I don't have any holes. Now, we got to remember that the parent graph here is in the bottom left and the upper right. There's no negatives here that would cause anything to be flipped, so then I'm just going to sketch my graph. Something like this. And that's all there is to it. Okay, so number 2, we already realized the degrees were the same, so we took the leading coefficient, so our asymptote was at y equals 1/4. Now our vertical asymptote, we take the bottom and set it equal to 0. So 4x equals 0, we divide by 4, and x would still equal 0. So on the y-axis, we have our vertical. Okay, then we take the top and set it equal to 0. Nothing canceled, so there's no holes. But for our x-intercept, we set the numerator equal to 0, and then we solve. We get x equals -3, so at -3, we're going to cross the x-axis. So, again, we start over here, kind of hit that x-intercept. And because of how hard it is to draw that asymptote at 1/4, that gives me the general idea. Okay? Alright. Okay, so 3. Now notice here, we have -2x minus 4. So that negative, we could pull out a -2, right? And simplify it to be x minus 4 over -2 times x minus 2. Okay, so this one's going to have a negative. So with the parent graph looking like this, that negative would make it look like this. Okay, just in case you run into that situation. But we look at our degree, 1 and 1, so we take the coefficients, so 1 over -2, so horizontal asymptote is y equals -1/2, so So at negative 1/2, I draw my horizontal asymptote. For a vertical asymptote, take the bottom, set it equal to 0. So negative 2x minus 4 equals 0. Add 4. Negative 2x equals 4. Divide by negative 2. And x would equal negative 2. So at negative 2, here I have a x-intercept. Then we take the top and set it equal to 0. Oh, I mixed them up. We were doing vertical asymptote, weren't we? So at negative 2, I draw that vertical asymptote. For my x-intercept, we take the top and set it equal to 0. So we'd end up with x equals 4. So it goes right there. Okay. And because of where the x-intercept is, we go like that, and we go like this. I know I just said that negative will change it, but apparently not all the time. It depends on some of the other information. So I wouldn't always take that as a rule of thumb. Probably because it dealt with where our vertical asymptote went. Alright, number 4. Okay, so x and x, they're both 1s, so it'd be like a negative 1 over 1, so our horizontal asymptote is negative 1. For our vertical, we go x minus 1 equals 0, add 1, x equals positive 1. So at x equals positive 1, we have a vertical asymptote. Then we go negative x minus 4 equals 0, add 4, negative x equals positive 4, divide by negative 1, and so our x-intercept would be negative 4. So negative 4 goes right there. So no holes because I haven't been canceling anything out. And my graph would look like this. I guess with the negative on top, it made it a negative, but that would have been different had it been x plus 4. So I guess all those pieces play into it. All right. Okay, number 5. So this top here, well, I guess x squared and x squared, so they're the same, so 1 over 1. So it would be a 1 for our horizontal asymptote. Okay. Now we've got to simplify this. And this x squared minus 1 is like x squared minus 1 squared. It's a different of squares, so I go x minus 1 times x plus 1 for the top. For the bottom, we could pull out an x, and we'd be left with an x minus 3. Okay. So on the top, for our x-intercepts, we're going to have a positive 1 and a negative 1, right? Because it always becomes the opposite. So honestly, you probably shouldn't need to do this every single time, but just realize that it ends up being opposite. So positive 1 and negative 1, we have it. Okay, now the bottom, set those equal to 0, and we get x equals 0. So we have a vertical asymptote, and I'll do this one in yellow again, at 0. We also have one at positive 3. Like I said, we could have more than one. And this is going to cause kind of a weird thing to happen. Okay? Then nothing canceled, so there's no holes. Now, so we know that this side is going to go down and hit that. Okay? We also know, just like on the old school video games, this will come out of space, but it'll jump over the asymptote and come up here. Okay? But we've got to get down to here. So when you have more than one vertical asymptote, in the middle, it's almost like the horizontal asymptote doesn't matter. So I start up here, I'm going to go through that, and then I'm going to kind of go down again. which then I jump back up, and I end up with it like this. Okay, so that middle zone, it's almost like you don't have that horizontal asymptote because it has to get to the certain pieces. Okay. Alright, now number 6 we did in class, but I'll do it again for those that weren't there. Okay, now we have the time when the top is bigger than the bottom in degrees. And that gives us a slant asymptote instead of a horizontal one. The way we find that is through long division. So I take the bottom, 3x squared minus 3x minus 6. I'm going to divide it into the top. Now, if there's a x term that isn't there, I think of that as 0 and that term. So it'd be x cubed minus 0x squared minus x minus 0, or plus 0, doesn't really matter. Okay, so now I've got 3 terms, so I go to the third term, and I got to match up the first terms. So how can 3x squared becomes x cubed? Well, to get the x to be this x cubed, I multiply by 1x. To get 3 to become 1, I have to multiply by its reciprocal, 1/3. Okay, so then I take this and I multiply it by all 3. So I get x cubed minus x squared, because 3 times 1/3 is 1. X times x is squared. And then negative 6 times 1/3 will be a negative 2, because 1/3 times 6 is 2x. Then you change the sign and you add them, just like long division. That becomes 0, which is what we want. Negative x squared plus, or 0x squared plus x squared is x squared. Plus negative x and 2x gives us 1x. Drop down the 0. So we have 3 again. Take these. How can I make the 3x squared x squared? Well, I times by a positive 1/3. So I put a plus 1/3. So that gives me x squared minus x minus 2. Then we would change the sign and add again. I'd get 2x plus 2, which this is my remainder, which I don't care about. What I care about is this. That, as an equation, is my slant asymptote. Okay? So a lot of work just to find the slant asymptote. So we go up to 1/3, and up 1/3, up 1/3. Oops, that was only over 2. And somehow I got rid of all of them. That's weird. Okay, then down 1. Those are horribly off. Let's try that again. And they're probably going to be off. It's hard to make it work. So here, oh, sure. Here. So there's our slant asymptote. Okay. Now we can simplify it. X cubed minus x, plot an x, and I get x squared minus 1. Well, we dealt with that, right? That's a difference of squares, so it's really x minus 1 times x plus 1. In the bottom, I can pull out a 3 out of all of these, so I'd have 3 times, and that would become x squared minus x minus 2. If I pulled out the 3, then factors of 2 that add up to negative 1, negative 2 and positive 1. So I have x minus 2, x plus 1. Okay, now we have something that cancels. So we're going to have a whole. Okay, so for my whole, we have x plus 1 equals 0 to find the x value of the whole. So I get x equals negative 1. To find the y value, you take the rest of it and plug in for x, negative 1. So negative 1 times negative 1 minus 1 over 3 times negative 1 minus 2. So negative 1 minus 1 is negative 2. Negative 1 minus 2 is negative 3, so 3 times negative 3. So for our y value, for this is our whole, right, we get a positive 2 over negative 9, so negative 2/9. So at negative 1, negative 2/9, right, close to there, that's going to be a whole. Now, if I could draw better on this, it would actually look hollow. Okay, so remember that. Then for the vertical, we go 3x minus 2 equals 0, divide by 3, x minus 2 equals 0, add 2, x equals 2. So at x equals 2, there's an x-intercept. Or no, not an x-intercept. I keep mixing those up, don't I? Vertical asymptote. That's why having that frame handy is very helpful. The top is for the x-intercept. So I have 2, x and x minus 1. So let's see, this was vertical asymptote. Maybe I should label things, that might make it easier. X-intercept. So x equals 0 and x minus 1 equals 0. Add 1, we get x equals positive 1. So positive 1 and at 0, I have 2 x-intercepts. So I climb up here, go over, hit that hole like that, and then I go to the other side and do it like that. Alright, let's keep on trucking with the rest of them. Okay, so x and x squared. Okay, top is smaller than the bottom. X-axis is my horizontal asymptote. Okay, then I want to simplify to see if anything gets eliminated. So negative 4x plus 1 over, pull out an x, x plus 3. Nothing eliminates, no holes. Vertical asymptotes at x equals 0 and x plus 3 equals 0, so x equals negative 3, right? Because we'd subtract 3. So at 0 and at x equals negative 3, vertical asymptotes. Okay. Then, so that was vertical asymptotes. Then we have, for the top, even though we have this x-axis, because we said that in between more than one vertical, it's like it doesn't exist. Okay, x plus 1 equals 0. For my x-intercept, we'd have 1 at negative 1. Okay, so there's going to be an x-intercept here. And this is where it gets tricky because we don't have any way to know. Do I go this way or do I go this way? Okay, and so the negative on the top, kind of like we had back here on this one, okay, that made it reflect. I think that should be it. If you're not sure, graph it to double check. So with that said, it looks like this. So it goes up, then I have to jump the screen, go through my x-intercept, back up, and then we go back down here. And it should look like that. Okay, number 8, same top and bottom, so negative 1 over 1, so negative 1 is my horizontal asymptote. Okay, then we can pull out a negative 1, so I get negative 1, x squared minus 16. 16 is really like 4 squared, so the top becomes negative 1 times x plus 4, x minus 4. Okay, for the bottom, factors of negative 3 that add up to negative 2, negative 3 and 1, so x minus 3, x plus 1. Okay, so nothing that eliminates, so no holes, 2 verticals, right? So that'd be at a positive 3 and a negative 1. Okay, the top, okay, for x-intercepts, positive 4 and a negative 4, right? So a negative 4 and a positive 4. Now this is where it gets kind of interesting, because according to where these x-intercepts are, that's going to look like that. Okay, but notice here, both these go up, so from down here, they're going to have to go up, but come back down here. It can't go up through. Plus, there's no x-intercept here. So it's going to rise up and kind of get close, and then come back down. Cool. Which can form a pretty cool graph, as my daughter just said, which you probably heard that. So, sometimes, so you got to pay attention to what's going on in there to determine if it goes up or if it just curls. Okay? Alright, we got 4 more to get through in 10 minutes. Alright. So, number 9, x squared, same, so I choose the leading coefficient, so at negative 3. We have a horizontal. Okay. To simplify the top, I could pull out a negative 3. I'd be left with x squared minus x minus 2, which would simplify to x minus 2 times x plus 1. The bottom factors of negative 6, it would be negative 1, would be x plus 2 and x minus 3, because 2 times negative 3 would give me negative 6. Nothing cancels, so no holes. Okay, so at the bottom, our vertical, that would be a negative 2. That would be a positive 3. So negative 2, positive 3, vertical. Top, we've got 2x intercepts. So at a positive 2 and a negative 1. Okay. Now notice again, they're both here. So if I go down through here, I'm going to have to curl back up through that one, which means this would go right here. Oh, wait, not that side. Opposite, right? So we'll go down here, and this one would go down here. And there's that one. Okay, number 10, same again, so it would be negative 1/4. So really close to the x-axis for my horizontal asymptote. Okay, the top, can pull an x out to simplify, so it would be x times x minus 1. Over the bottom, I can pull out a negative 4. So if I did that, it would be negative 4 times x squared minus 3x plus 2. Factors of 2 that would add up to negative 3 would be negative 1 and negative 2. So if you needed to, you could use a box method or realize it's just going to be x minus 2 times x minus 1. So 4 times x minus 1 times x minus 2. Okay, now 1 can cancel out, so we're going to have a hole there. So x minus 1 equals 0. Solve, and we know it's the opposite, positive 1. Then to find the y value, I take the leftover x over 4 times x minus 2, once we get rid of these. Okay, which that becomes my x-intercept, right? Which is pretty simple. X equals 0. That becomes our, so let's see, x-intercept, vertical asymptote, x minus 2 becomes positive 2, right? So we can shortcut those. So positive 2 of vertical. Okay, but then, to find the whole, becomes negative 1 over 4 times negative 1 minus 2. So negative 1 over 4 times negative 3. So negative 1 over negative 12, which is just 1/12. So 1 and 1/12. So 1 and 1/12, so really barely above is going to be a hole, right about there. So then draw my graph going like this, jump to the other side, and it looks like that. So quite a bit of work there. Alright, last two. Okay, so x squared and x cubed. Top is smaller than the bottom, so right on the x-axis. Okay, factor out an x, so I get x times x minus 2, over, factor out 2x, so 2x, and I get x squared minus 4, which 4 is really 2 squared, so that's a difference of squares, so I actually end up with x minus 2, x plus 2. So those cancel, so I'm getting a whole. X minus 2 equals 0, so add 2, x equals positive 2. What about the y value? Well, I split it up, x over 2x times x plus 2. So it would be 2 over 2 times 2 times 2 plus 2. So 2 times 2 is 4, 2 plus 2 is 4, 4 times 4 is 16, 2 over 16 reduces to 1/8. So really close to 0. So at 2 1/8, there's a hole right down there. Now for x-intercept, x equals 0. Okay, so now we may say, how's that going to happen? Well, let's just watch and see. Bottom, we've got 2, so 2x equals 0 for our vertical asymptote. X plus 2 equals 0. So at negative 2, we have a horizontal asymptote. So because we have two horizontal or vertical asymptotes, we can have the middle thing going on. Which is why generally I like to do the vertical asymptotes first. Divide by 2. And I didn't realize something. Those x's could cancel out, so we actually have two holes. Okay? So we wouldn't have an x-intercept, because those x's would cancel out. We'd have another hole at x equals 0. Okay? So we wouldn't have this vertical asymptote. We would only have the 1. So, and we wouldn't have an x-intercept. So that was my mistake. That should have canceled out from the beginning, and we would have been left over with 1 over x plus 2, which is going to change that as well, and we have to redo a lot of stuff. Okay? Oh, and that's 2 times. So, oops. So the hole would be x equals 0 and x equals 2. So I plug in. So the vertical asymptote would still be x would equal negative 2. Okay, but plugging this, I go 1 over 2 times 2 plus 2. So I get 1 over 2 times 2 plus 2 is 4, which I actually still end up with 1 over 8, don't we? But if I do 0, we get 1 over 4, because it'd be 2 times 2 in the bottom. So at 0 1/4, we have a hole, and at 2 1/8, we have another hole. So it would come down like this, and then jump to the other side like that. Okay, so we got to be careful of recognizing when those get eliminated too. Alright, now we got the same. So 1 over 1, so positive 1. And then we factor. So the top would factor down to x plus 3 times x plus 1, because 1 times 3 is 3, 1 plus 3 is 4, over the bottom would be factors of negative 4 that make negative 3, would be a negative 4 and a positive 1. So those cancel out, and they're the only ones. So vertical asymptote, or horizontal asymptote, at y equals 1. Vertical asymptote, x minus 4 equals 0, so it would be x equals positive 4. Okay, an x-intercept at x plus 3 equals 0, so x equals negative 3. So negative 3 x-intercept at x equals positive 4, vertical asymptote. Then the hole would be, let's see, this was negative 3, 0. Then for the hole, we'd have the x plus 1 equals 0. Minus 1, we'd have x equals negative 1 for the x value. Then plug it into that remainder, and we'd have negative 1 plus 3 over negative 1 minus 4. So negative 1 plus 3 is 2. Negative 1 minus 4 is negative 5. So it would be a negative 2/5. So at negative 1, negative 2/5, some hole right there. So start right here, hit that, goes down this way, then you jump up to the other side, and there we go. And there's our rational functions.